all the speakers here and welcome all the audience. Okay, let me introduce myself. I'm Assistant Professor Dr. Erika Pritchikiti. I'm delightful for being here. I will be your facilitator for this section 1 on the plastic pollution fact and way forward solutions. Okay. Again, I would like to say good afternoon to all the colleagues from Mahidol University, with both based in Kanchanaburi Campus and also Thai and also the Saraya Campus. Okay. Also I'm very welcome the special guest from Chulalongkorn University, Professor Thachhavee. Okay, she will give us the special talk on the plastic pollutions, and waiting for a few moments. Okay. Also, this event cannot be complete without our great companion from UK, University of York. I would like to say good morning to Professor Blake Salage. I'm not sure, do I correctly pronounce you? Okay, thank you. And Professor Kelly Redeker. Also the Professor Richard Friends. Okay, Swadee ka. Okay, thanks all for being here, and also Fawn, right? I think there is also a couple professor from University of York. Please you introduce yourself. I'm not. It's not in my list as well. Okay. I think there is a couple of you that is not in the list of the speaker, but please introduce yourself to all the audience.
I think that includes Professor James Chong. Hello.
James Chong.
We have Dr. Karen Parkhill as well, I think.
Yes.
Hi, everyone.
Oh, Karen. Okay. And Mark.
Oh, Mark. Yes, sorry, Mark. Mark Hodson.
Sorry, what? Do you just want us to introduce ourselves, do you?
Yeah, just say hi.
Okay. Hello, everyone. My name is Mark Hodson. I'm a professor in the Environment and Geography Department at the University of York. I'm a soil scientist.
Okay. All right. Okay. Thank you all for being here. Okay. This one is not here yet. Okay. But for the MU side, I think it's also a good time that we should introduce ourselves as well. Start by myself, Assistant Professor Dr. Erika Pritchikiti from Mahidol University based in Kanchanaburi Campus, from the Department of Environmental Engineering and Disaster Management. Okay. Next to be Ajahn Thamath.
Good morning and good afternoon. I am Thamath Gyalsuk from the same department as Erika. We are in Kanchanaburi. It's rainy day today and good to be here and nice to see you all. Thank you. Hi.
This.
Monchai.
Maybe Ajahn Monchai. Just quick introductions.
Okay, good morning and good afternoon, everyone. I'm Monchai Punkel. I'm the head of Department Environmental Engineering and Disaster Management. Nice to meet you all again. Thank you.
Maybe Ajahn Orathai from Chulalongkorn University. Ajahn Orathai, could you turn on your microphone, please?
Sorry. Hello.
Ajahn Orathai, you turn off your microphone again. Please turn on your microphone. Yes.
Okay. I'm Orathai Chawan Palit. from Department of Environmental Engineering, Faculty of Engineering, Chulalongkorn University. Yeah. Nice to meet you.
Thank you อาจารย์ตวงอาจารย์ธรรมนิกพล
Good
Yes,
morning,
please.
everyone, and good afternoon from Thailand. My name is Thammanipon Denpetkul. You can call me Chui from the Tropical Medicine, Mahidol University. Nice to meet you all.
Okay อาจารย์ลักษณาลี I saw from the list you are here
Yeah. Hello, everyone, and good morning from UK side. My name is Laksanari Chon, or you can call me Fern. I just joined Mahidol University Kanchanaburi at the beginning of this month. It's my pleasure to join all of you here and to meet you here. Thank you very much.
อาจารย์เนติยา Thank you อาจารย์แก้ว อาจารย์เนติยา from also from Mahidol Kanchanaburi Campus and อาจารย์นิธิมา
I'm from Mahidol University Kanchanaburi Campus, and I'm come from the agricultural science. Maybe it's the good opportunity to hear from the pollution in the environment from this webinar. Thank you.
อาจารย์นิธิมา from Kanchanaburi Campus as well maybe she's not here
Hi, hello everyone.
Ah.
I'm Nitima Sutapin. You can call me Nancy. I'm from Kanchanaburi as well, and very pleasure to have you be here to join your session and exchange knowledge because I'm majoring teaching English language. Thank you.
Okay, next is อาจารย์สิรินันท์okay maybe quick อาจารย์สิรินันท์ just say hi yes good morning she also from Department of Environmental Engineer do I miss somebody อาจารย์อรชา
Could you please introduce Ajahn Atit Posi, please?
อาจารย์อาทิตย์ yes he also from the Public Health Department of Public Health อาจารย์อาทิตย์ just say hi อาจารย์อาทิตย์ because you're gonna
Hi everyone, my name is Atit Posi. Nice to meet you all.
Okay. He will give us a talk in the second part of this webinar. All right. So, okay. May I proceed this webinar by inviting our Vice President for Information Technology and Kanchanaburi Campus, Assistant Professor Dr.Thatchavee Leelawat, to give us the opening remark. Please, Ajahn Thatchavee.
Right. Good morning, everyone. It's my pleasure to welcome delegate from University of York to this seminars between University of York, Mahidol University, and we have colleagues from Faculty of Faculty of Public Health, Faculty of Tropical Medicine, Faculty of Environmental and Resource Studies. And it's a very honor that we also have professors Oratai Shoparit from Chulalongkorn University. She is director of Solid Waste Management Association of Thailand. Thanks to colleagues from York and MUKA to organize this meeting. I'm sorry. I'm very, very sorry that to be a little bit late on that part. This first seminar that bring together academics from the university to exchange knowledge and experience in this very important global issue, just like solid waste management. Solid waste management has been a great challenge from Thailand and of course for others universities, other countries as well, which And other thing that we're going to discuss today is about plastic pollution that has become another big challenge, and it is even worse with the COVID situation because they're going to use quite a lot for this part. Today's event in this theme of law of academia for plastics pollution solutions is a very good start of our collaboration, which I have confidence that upcoming cooperative projects will contribute to solutions to the global problems. It is wonderful to see the strong collaboration in the near future to work together for the good causes and for the sustainability of the world we live in. It is very enthusiastic to see this kind of collaboration happening in our university, Mahidol University. Always support international collaboration and any academics activities, especially research, which we truly believe that it will help strengthen our strengths in the global platform. I hope you will enjoy this discussion and networking. Thank you for your participation. Thank you so much for everyone. Okay, thank you.
Thank you so much, Assistant Professor Dr.Thatchavee Leelawat, for the opening remark. Okay, before we move on, we should have a group photo. So please, everyone, turn on your camera. Just take a couple minutes. So film take รูปหน่อยนะ Yes. Okay. Turn on your camera, please. นักศึกษาด้วยนะคะ all the student as well. Okay. ฟิล์มให้สัญญาณหน่อย
Okay, ready? 1, 2, 3. Again, please.
ทุกหน้ายังฟิล์ม
สักครู่ครับ Just a minute.
เสร็จยังฟิล์ม
Again, please. 1, 2, 3. Okay, thank you.
Okay, thank you everyone. Okay, I want to take a couple minutes to let you know about the objective of this webinar. Okay, this webinar is organized to provide us the understanding and also opening our mind and our eyes on the plastic pollution situation in both Thai context and UK context. We both different in environment, climate zone, and social norm, and also the religions and politics. Okay, this may more or less affecting our waste management. Okay, after we listen from both about each other, we can share with us or we can fine-tune our perspective on the research and development. Okay, in the area of plastic pollution, so that we can fulfill our both demand and supply between us. Okay, we wish that this activity will be as the commencement of our collaboration, especially in the research and development. Actually, Mahidol University open room for us to develop joint activity. It can be in form of the joint laboratory between both institutes. Okay, so it might be possible in the near future, but this webinar will be a kick-off activity before we move forward further. Okay, we wish that this webinar gonna be very useful and successfully done. Okay, so we come into our schedules. I would like to welcome Professor Thachhavee from Chulalongkorn University, and she will provide us the special talk on the plastic plastic waste issue in Thailand. What are the main challenges and expected solutions? Professor Orathai is currently the professor in the Faculty of Engineering, Department of Environmental Engineering. Her expertise is on waste management, particularly in the industrial sector. She has a countless number of publications on the clean technology, and also she also have the publication on the plastic waste management in Thailand. So she very fit on this position. Please, Professor Orathai. อาจารย์ turn on เปิดไมค์ด้วยค่ะ
Thank you อาจารย์อลิกาcan I share my slide
I think you can share your slide ฟิล์มแชร์ได้เนาะ
ใช้ได้
ใช่
No I cannot share
อาจารย์แชร์ได้ไหมครับ
ไม่ได้เลยค่ะ
อาจารย์กดแชร์
มัน
กดแชร์
ขึ้น
แชร์สกรีนนะคะอาจารย์
ขึ้น switch to desktop แต่ว่า click allow
คลิก
on
ต้อง
prompt
แชร์ค่ะอาจารย์อยู่ข้างล่าง ข้าง
แต่
ๆ หน้าคนยิ้มอยู่อะค่ะ
ค่ะแต่มันแล้วเขาขึ้นว่า switch to desktop app แต่ไม่ขึ้นอ่ะเดี๋ยวดู
อาจารย์ติด
ส่งสไลด์ให้อาจารย์มนชัยไหม
อ๋อค่ะดีกว่าเนอะ
ค่ะ
นะครับอาจารย์หรืออาจารย์ส่งให้ผมก็ได้ครับ
เดี๋ยวนะคะ
ส่งทางไลน์ก็ได้นะครับอาจารย์
ค่ะได้ไหมคะ
ให้ผมแชร์เลยนะครับ
ค่ะ
Excuse me, can you see the slide?
yes
we can see
Okay my presentation topic is plastic waste issue in Thailand challenge and expected solution Okay next slide please I would like to introduce my research project. My research project is on circular economy implementation, and for the last few years, I'm do research on solid waste management, like a food waste survey, plastic waste recycle. Yes. Next slide, please. For plastic waste management in Thailand, in 2016, global plastic production was about 300 million tons and is expected to double in the next 10 years. Plastic share of oil and gas consumption of about 6% of global oil and gas production. Only 9% of plastic waste generated was recycled, and 13 million tons of plastic waste dumped into the ocean each year. Next, please. Thailand is one of the main plastic producer and contributor of plastic in Asia. The plastic and resin production was about 8.5 million tons in 2017. And for Thai people, plastic packaging consumption was about 15.5 kilograms per person per year. And the result, you can see that 18% of plastic waste contribute in municipal solid waste. Each year, you can see that 2.5 million tons of plastic waste in landfill. And now plastic waste management is a national agenda. It is estimated that each year about 50,000 tons of consumed plastic leak into the sea. This leakage promotes Thailand as the sixth of the list country of the most waste polluter by plastic waste debris left to ocean and sea. Yes, next. This figure shows the portion of packaging plastic waste in municipal solid waste. You can see that about 84% of plastic contained in municipal solid waste are plastic bags, like a HDPE bag, 46%, LDPE bag, 24%, and PP bag, about 14%. So such plastic waste are contaminated and have low potential to be recycled. The cost of collecting and cleaning this type of plastic waste are quite expensive. So there are no potential to be recycled. Next. In current practice, local government is responsible for collecting municipal solid waste and disposal to landfill and incineration method, while waste collector collect plastic waste from waste generator and then supply recyclable plastic waste to waste shop and waste recycle. Finally, recyclable plastic waste is converted to plastic recycling plant. Plastic waste at dump site have low potential to be recycled since they are contaminated. So this informal sector take action on plastic waste recycling in Thailand. From the figure show composition of packaging collected for recycling across different activities. You can see that most of plastic bottles are collect and recycle, and tray, cup, plastic cup is also collect and recycle, but plastic bag is return, cannot recycle. So plastic bag is a problem of municipal solid waste in Thailand. Next. please. Next slide, please. เอ๊ะ no กลับมาอีกอันหนึ่งค่ะ yes ค่ะ Thailand has a regulation on plastic waste management in 2017, such as, for example, Plastic Debit Management Plan. They act on the promotion of marine and coastal resource management, national roadmap for the development of bioplastic industry, and the government also have action on plastic waste management, such as pilot project on plastic waste collection in coastal area, public-private partnership on plastic cup seal phase out, and pilot project on plastic waste collection. Next. Yes. This figure shows timeline showing Thailand progress and future commitment for zero plastic waste. In 2018, the Thai government kicked off a campaign to reduce the use of foam container and single-use plastic bag. In 2019, Thailand formally adopted the roadmap on plastic waste management, and we have guidelines for plastic waste management. And in 2020, a ban on single-use plastic bag with a thickness of less than 36 micron at major retailer, and for the target is in 2027, the target for 100% recycled plastic. Yes. Next, please. For guideline for plastic waste management, the first goal, waste production and plastic packaging are returned to reuse, reduce, and recycle 100% in 2027. Second goal, plastic product and packaging were decreased or using environmental friendly renewable material. Yes, in the next year, disable single-use plastic packaging thickness less than 36 micron plastic, and plastic glass thickness less than 300 micron, and straw will be banned. Yes, next please. So we can conclude that the critical issue and opportunity for Thailand is public collection coverage for only 75% of Thai population, and bottle and plastic bag are major plastic packaging waste in municipality waste. Most plastic bottle, about 70%, are correct for recycling. And the most important is only 12% of packaging plastic waste is separated by household. And for this figure, you can see that most of plastic are improper management, like open burning, unsanitary landfill, and incinerate. Some plastic waste remain on land. Only small portion, the green one, is some only portion that can be recycled. For PET, bottle PET take high portion of recyclable plastic. For HDPE, like a milk container or shampoo, consumer good can be recycled, but very small portion. Yes. Next, please. Key barrier to plastic waste recycling and management in Thailand. The consumption pattern of Thai people involve the high use of plastic bag as food container, which contaminate the bags and make them unlikely to be reused and recycled. For legislation and regulation, lack of regulation of plastic producer to provide a plastic resin identification code like this symbol. There is no regulation. And for producer, lack of financial incentive for plastic waste recycling. Next, please. Yes. Option to improve awareness of plastic waste management is first, the important is people. Increase public awareness for people to reduce, reuse, and recycle. Reduce single-use plastic. Reduce plastic packaging and segregate plastic waste at the source. Next. For legal measure, government should set national target for waste collection, segregation, and recycling. Invest in national or regional waste management infrastructure. Revise the law to set fee for plastic bags or adopt an extended producer responsibility policy. And promote environmental education and awareness to adopt sustainable consumption at all levels. Yes. For private enterprise or producer should reduce use of plastic, use recycled plastic or bioplastic as raw material, take responsibility for product end-of-life impact from the design, and implement circular economy principle in their organization. Yes. Next. Next, please. This is a circular economy model for plastic waste management in Thailand. The producer should reduce the consumption of petroleum-based plastic, reduce fossil raw material, non-renewable energy, and use recyclable plastic or bioplastic as raw material. The green one is bioplastic. Yes. People for producer, they should adopt eco design for their product. And for people, they should reduce plastic consumption and use durable plastic product and segregate plastic waste at source. This is a circular economy model for plastic waste management. Yes. This is thank you for your attention.
Thank you
Really
very
have-
much, Professor Arathai Chawaparit. See, you can see this is the Thai style of waste management. People from UK might not know the career called waste scavenger. Do you have a waste scavenger in UK? A waste picker in UK? So if you visit Thailand, you will see this is a very famous career. So you could it's illegal, but they have this kind of career as well, and it's also in the waste management system in Thailand as well. Important part. Also, you can see that the government or we have the good regulation to minimize the amount of plastic waste. We set aim very high that 100% recycled plastic in 2027, and let's see that we can achieve or not. Okay, next presentation is from University of York, presented by Professor James Chong on the title of the broader research themes, waste as challenge for all society. Okay, Professor James, please share us.
Thank you very much. Hopefully you can see my screen now.
Yes.
Great. Hello everyone. It's very nice to be part of this meeting today and to talk to you a little bit about some of the broader activities that the University of York has that I hope will be relevant to some of the people attending this workshop today. So I work in the biology department at the University of York, but I'm mainly going to talk about other activities that the university has going on. If I get my screen to, okay. So I'm sure you're all aware of the water, food, energy nexus and how waste is a large part of this. So if we consider globally, obviously energy is required in order to produce clean water for drinking and human consumption. And at least in Europe, about 20% of all the fresh water that is produced is lost through leakage across the water networks that supply the water to various parts of the countries. In addition, a very large amount of food is wasted every year or lost. The estimates are something like up to 50% of global production. That's 2 billion tons of food every year. This is lost in different ways. In lower income countries, most of the loss tends to occur during production. And in developed countries, most of the loss is at the consumption stage. So people actually buy food and then just don't use it, and so it gets thrown away. And the estimate is that can be up to 100 kilograms per person per year wasted due to consumption. And of course, there's also losses in energy through the water that is lost. We're basically losing energy because the clean water is being lost. Inefficient lighting, heating and cooling in different parts of the world, and other inefficiencies associated with food, such as the way that the food is transported to different parts of the world or different parts of the country where it's consumed. So, how is this studied at the University of York? We have a number of different institutions that are involved in this. The first one I'm going to talk to you about is the Stockholm Environment Institute at York. So SEI is an independent international research institute that has offices in a number of different parts of the world. Its headquarters are in Stockholm, but it also has offices in Bangkok, Bogota, Nairobi, Oxford, and Tallinn, and across the US. The University of York is home to one of the UK parts of SEI. This institute is focused on environment and development research, has been for more than 30 years. It helps support decision-making and change towards sustainable development, and it advises governments and UN agencies regularly at the highest levels. In York, the themes that are concentrated on by SEI are sustainable consumption and production, nature-society relations, how people interact with their surroundings, and air quality and climate and environmental change. So SEI workers are integrated in our environment and geography department at the university. We also have the York Environmental Sustainability Institute, which is also locally known as YESI. This is a way of bringing together all the researchers within the university who have interests in either environment or sustainability issues. We have more than 100 researchers at the university who are interested in this area across 17 different departments within the university. And we've partnered with more than 130 external agencies in the work that is carried out by YESI as well. So YESI's main interests are in sustainable food, resilient ecosystems, and environment and health. And within that, we have a number of networks. So we have, I guess, probably most relevant to the meeting today, what's called the Waste and Resource Use Network, which I lead. And below that, we have WasteShed, which Richard Friend, who's also on the call today, has been in charge of, and Kelly Redeker is heavily involved with. And we have a plastics network, which Karen Parkhill is involved with leading at the moment. And in addition to that, we have interests in tropical ecosystems and the climate change network. So all of these researchers are very interested in how they can bring their various expertise to understand and tackle these problems. Excuse me. In addition to this, the university is involved in a number of initiatives across the region. The University of York is based in Yorkshire, which is in the northern part of the UK. And we are involved with these 3 different initiatives. BioVale, which provides support for bio-based innovation and businesses. That again has around 600 members that are interested in the greener economy. And BioVale is there to facilitate networking between the university and business members, but also between other business members. And it promotes the region nationally and internationally as a centre for expertise and specialising in bio-based business and research and development. BioVale has led to an initiative called BioYork, run by the university, that has 3 main research themes. The idea of novel uses of natural solutions for healthcare and pharmaceuticals. It has a focus on how we can improve productivity, sustainability, and nutritional value of crops and food, and also in developing new sources of bio-based fuels and chemicals. And finally, and most recently, the university has been involved in an initiative called Bio Yorkshire, which again is focused on delivering green economic growth in partnership with 2 local other institutions, Askham Bryan College, which is an agricultural institution, and Ferroscience, which is the food and environmental research agency, which used to be a government agency, but now is an independent agency that regulates and looks after things like pest control for things like imported foods. And the Bio Yorkshire region is Bio Yorkshire initiative, is focused on supporting the region to become carbon negative. And actually just today, Bio Yorkshire is launching a bioeconomy massive online open course for people to learn more about issues around the bioeconomy. The University of York also has a Green Chemistry Centre of Excellence, obviously manufacturing molecules that can be used in place of those that rely on fossil fuels becomes increasingly important. And this is a world-leading academic facility for pure and applied research that uses sustainable technologies to produce molecules that are useful as building blocks for the materials that we use in everyday life. The Green Chemistry Centre of Excellence has particular expertise in microwave chemistry, which is obviously one way of introducing energy into molecules which is potentially more efficient than heat and pressure. It has expertise in alternative solvents, clean synthesis, and other bio-based materials. Associated with all these efforts is the Biorenewables Development Centre. So this is a wholly owned subsidiary of the university, which sits at the interface between traditional university scale research and industrial production. So the BDC has facilities that allow us to look at scaling up processes and works mainly in the 1 to 100 kilogram scale, which means that we can try out processes that have been developed in the lab and check that they're going to work or identify the problems that might be caused by trying to scale some of these processes as they go into the wider economy. So we have this open access research and development biorefinery centre, which has a lot of different facilities. The BDC spend a lot of time, again, working at the interface between academia and industry, carrying out industrial research where they're contracted to do so. And they have particular interests in plant biology, microbial biotechnology, and how bio-wastes can be turned into biorenewable products. Right, I'm now going to just spend a couple of minutes talking about my specific research, if that's okay, because hopefully some of this is relevant to what was just discussed. So my group is interested in this process, the production of biogas by microbial communities. Biogas is produced from organic waste, and it happens as a natural process. Oops, sorry. Seem to be going to watch that again. This process of anaerobic digestion is used at large scale, and as was mentioned in the previous talk, this can be used for all sorts of organic wastes. It can be used for sewage sludge that is produced in wastewater processing, but it can also be used to recover resources from food waste and from agricultural residues. So the picture you can see now is of a wastewater treatment facility near to York in the city of Leeds. And this facility takes sewage sludge and turns it into biogas, which can be a replacement for natural gas. And obviously those carbon molecules can also act as the basis of green platform molecules for recycling, for producing things like bioplastics. My group is very interested in how we can engineer the microbial community that produces biogas from waste materials, and how we can potentially make the process more efficient, but also how we can divert resources into more valuable molecules in green synthesis type approaches. So we work very closely with our local water provider, Yorkshire Water. They provide fresh water to our local population of about 6.5 million people. They also provide sewer services to them, so they're processing about 1.5 to 2 billion litres of water per day. You can see this is one of their large-scale facilities. Each of these containers has the capacity for about 7.5 million litres of sewage sludge. And within the university, within my lab, we have a small-scale facility that has 60, that's 60 small-scale reactors where we can mimic the large-scale process. We're interested in a number of technologies that will allow us to make the most of this process. So this is a piece of work that we did in collaboration with colleagues at the universities of Southampton and Sheffield, as well as some other commercial companies. Hopefully what you can see here is we've taken normal anaerobic digestion, which normally produces about 50% methane in the biogas, and we've gradually added hydrogen. And obviously we would expect the hydrogen to come from a renewable resource. As we add hydrogen to our system, we produce more and more methane. So this is a good way of potentially storing energy from renewable resources that can't be used immediately. So rather than using battery power, we can convert it to methane and store it as compressed gas. My group is particularly interested in understanding how the microbes change in these processes and how we might be able to manipulate the microbes in order to make those processes better and improve the value of the material that we can get from them. And that's everything I have to say. So thank you very much for listening, and obviously I'd be very happy to answer any questions you might have.
Okay, thank you very much, Professor James Chong. So your sharing is give us a picture that University of York has very solid on the biotechnology and bioscience. You have there many project and many excellent center that handle this kind of problem. You have BioVal, like and also Renewable Development Center. I think this kind of project and also the center can be give us the benefit as well in terms of the knowledge exchange. As Dr. Orathai said that in Thailand we have a lot of problem on the plastic, and she proposed for the bioplastic that easy to degrade. So I think this technology can be transferred to Thai scientists as well. I think your solid is going to be benefit for us. And also you mentioned, yes, you mentioned about the bioeconomies. And also Professor Orathai mentioned about the solution on the circular economies to handle the plastic waste in Thailand. So why not we join together? Right? So very perfectly matched. You have the knowledge. We still have gap on this. Just click it. Okay, next. Thank you. So next is gonna be to the Q&A sections. Anyone have questions so it's time for the questions.
I actually did have a question about plastic bags. So the UK has had exactly the same issue, I think, that Thailand is facing now. And one of the solutions has been to charge. So previously, plastic bags have been free to consumers, and now there is a mandatory charge, a mandatory minimum charge for plastic bags. And that seems to have made a really massive difference to how people use them, because they know a bag is costing them money now. And although it's not very much money, it still drives a change in behavior. Is this something that Thailand is planning to do?
Professor Oratai, do you want to answer? I think she mentioned about this fee of the plastic bag in her talk. Just be more clarified on this.
Yes, last before COVID-19 crisis, some department store or some supermarket, they charge the plastic bag, maybe 1 or 2 baht per one plastic bag. If consumer asks for plastic, they have to pay 2 baht for one plastic bag. But this year, because of COVID-19, the plastic waste increased.
Single-use plastic waste.
Yes, we use a lot of plastic for safe, for occupation health, for something. It's a problem.
Yes, may I share? I think the Department of Natural Resources, Thailand, have a big campaign on the plastic, single-use plastic bag, and the government try to do the campaign to rising public awareness on using plastic bag by distributing the bag from plastic bag to the people, but it seems that it's gonna be, it turned into the public sensations that some do a funny joke about that, but some is not. It's quite against of this policy, because I think we plastic bag is in our DNA. We get used to it. We adapted to it, but we don't know how to solve without plastic bag. Some do some joke that you go to the department store without plastic bag. So what you carry on? Somebody just do the funny thing, just anything else, but not plastic bag. Just try to make a joke on this. This year, no one make a joke and no one interesting about plastic bag issue anymore, because we still use plastic bag. Okay, อาจารย์จุธามา and also อาจารย์อรอัชรา
Yes,
would like to have
I would like to share some part of the plastic bag, single-use plastic bag in Thailand. Last year, almost 2 years before that, in Thailand, we have the campaign. Like, we did start from January 1st of 2020 that we will ban the plastic bag in the department store, but because of the COVID pandemic, so that campaign is like slow down. But one campaign that we have is not mandatory, but we have like the big convenience store in 7-Eleven in Thailand. We have the campaign that if you don't take plastic bag, you can donate, like donate for, I'm not quite sure, about 10 cents or 10 stang for that if you don't get plastic bag, and that donation will go directly to the big hospital in Thailand, which is Siriraj Hospital, and at that part they will gain they already gain a lot of money for donation. That is a campaign that is quite popular at that time, and after the COVID pandemic, that campaign is slowed down, and still we have that campaign in 7-Eleven, but not quite serious. Okay, thank you. That I would like to share.
Yes, thank you, Professor Oracha. Professor Oracha is from the Department of Natural Resources, Mahidol University, right?
Yes,
we apologize. I did not introduce you the first time.
From Mahidol University Salaya campus, also Faculty of Natural Resource.
Okay, right. Yeah, if I agree that if you want to raise the public awareness in Thailand, in UK you might charge for the waste, but in Thailand, if you do charging the waste, people say that I can pay. So if you do some this kind of thing, donation, Thai people love it. So we have different culture, social norm, right? Okay.
And I think that's very important, actually, to understand the differences between how people behave in different places to get them to change the way that they consume plastic or use plastic.
Yes, yes. So any questions? Okay. Ajahn Sudhama, should I raise your hand, please?
Yeah, okay. I just want to have a quick say about the plastic charge as a consumer. I think this campaign doesn't really effective because not every store, not every convenience store, they like join this campaign. So like for example, 7-Eleven, if we buy more than like 100 baht, for example, they will give us free plastic bag. So they encourage us to buy more actually, they can gain more profits. And for local market or like a local market, farmer markets, for example, they don't really have this campaign. They want to give us plastic bag because they don't want to lose customer. They are scared that if they don't give us plastic bag, we will not buy stuff from them. So I think we have to fine tune this campaign more after COVID situation. As this COVID, yeah. Yes, that's it. Thank you.
Okay, I think it should be the time for the second sections of this webinar. So please, Professor Richard, lead. You are leading on the second part.
Okay, thank you very much. Can you hear me okay? Yep. Okay, good. Right. Well, thanks very much, Ajahn Erika, for the first session. In this second session, we're going to invite colleagues from York and from Mahidol as well to present some of the research challenges and approaches specifically around plastic. And I have to apologize because there's a slight change to the agenda that you have in that Dr. Karen Parker will take the second session, and I'm going to just use this first introductory session just to give you a very, very brief introduction to a project and approach that Professor James mentioned in his presentation. So I'm going to try and share my screen, if that's okay. Oh, this is very strange, isn't it? Is that working?
Yes, it works, but it's small. Yeah, now it's fine.
Okay. Right. Better I lose my clock when I do this. Okay, so I just wanted to give a couple of minutes to talk about something that we've been involved in over the last few years, because I think it's an approach that perhaps has some relevance to what we're talking about and how we might cooperate and build a centre of research excellence between Mahidol and York. So a few years ago, we got involved with a number of different partners, including international NGOs, local NGOs, United Nations High Commission for Refugees, looking at problems around waste management in refugee camps. And this was became apparent that this is a priority area, partly because refugee camps are growing at an incredible rate, but there are also examples of very often very poorly organized, poorly structured governance arrangements, and that the problem of waste has very strong justice and equality issues, in that the people who are impacted by waste often are people like refugees and people around them very poor, very limited influence and voice, but also that the solutions to addressing waste can provide opportunities for some of these people as well. So as we were, and I should say that Dr. Kelly was also involved in this project, as well as a number of other colleagues from UK universities, international organizations, and NGOs. Spent some time, particularly in a refugee camp in Jordan that accepts refugees from Syria, and it very quickly became the second largest city in Jordan, given the influx of refugees. So they didn't really have time to put in place many of the sort of core systems that we depend on in cities, such as proper waste management, but then started becoming involved. International NGOs like Oxfam, pictured here, started supporting waste sorting, waste treatment, waste management. And we were very interested in looking at waste on this sort of broader scale, not just at the local point, not just at the end user point or where it is dumped, and trying to get a picture of, similar to a watershed approach in thinking about water, looking at how waste originates in certain places, is transformed, and then ends up in other places. And we were involved in this process working with different stakeholders within the refugee camp itself and in the neighboring communities, the established towns and cities close to refugee camps, who are also caught up in a similar waste shed. Ultimately, all the waste, whether it's from the refugee camp or from the city, ends up part of the same complex system. So we developed with our partners this idea of thinking about waste from this waste shed concept, understanding all the different forms of waste, where they originate, how they're processed, who's involved, what rules, what laws, what prohibitions there might be to encourage or discourage waste management, and where waste ends up. And learning really that the waste from the refugee camps has impacts not just within the refugee camp. And indeed, some of the waste from the refugee camp ended up being from Jordan, ended up being sent to India to be processed, so that pickers were organized to pack the cardboard waste, which was then sent to India. So it's really important to see waste from this sort of broader perspective. And of course, the advantage of us working together across Thailand and UK is to recognize that we ourselves are, in the UK, are major contributors to global waste. And while we, in many ways, have very good sorting and management systems in the UK, it's increasingly become aware to us here that much of the plastic that we very carefully sort at a household level ends up being shipped across the world to be processed in other parts of the world. So we are also major, despite what we do within our own homes, within the UK itself, we're major contributors to the global problem of waste, and particularly of plastic that is recycled here. And I'm very much aware that this is a picture from Prakanong in Bangkok, that as well, this is a very complex issue, that it's not just about people's behavior. When we don't have the incentives to manage waste properly, or even the mechanisms, as Ajahn Oratai has said, that you don't have the functioning waste collection systems and the waste disposal systems. And so we've kind of started thinking of waste in a sort of a broader way, and being particularly interested in the drivers of plastic use and the constraints against management. And something that's really struck me in Thailand is that the plastic bag industry, for example, is a very lucrative, large-scale industry. In the UK, we receive plastic bags, for example, for managing waste from dogs and other animals is produced in Thailand. So it's a major industry. and that is encouraging the use of plastic. The part of the industry business strategy is to encourage use of plastic and more use of plastic. So if we're to look at the challenges of how to manage plastic, we have to understand these underlying drivers and how they operate as constraints against effective management. So from the perspective of the waste shed that I mentioned earlier, we were looking at waste and pollution from both as a governance challenge and a technical challenge, and that the solutions lie both in the realm of governance change and technical change. So we've developed this way of thinking about waste, you might call a socio-ecological technological system, as all these different dimensions, the environmental dimensions. But we also need to think or be aware of how we understand, how we think, value waste and pollution, and people have different ways of understanding and talking about these problems. That waste, plastic pollution involves a whole range of different actors and stakeholders with different motivations, different interests, different agendas, and that there's a whole range of technologies and infrastructure involved in the whole process of waste from this broader waste shed perspective. And cutting across all of this is a whole range of different, as we've already said, different institutions, different social, cultural norms, different laws, different policies, and different governance arrangements. And this really leads us to recognizing the importance of bringing together a whole range of academic disciplines from different, that bring together different perspectives, and also of us working in different contexts, as we ultimately we're all connected across this global waste shed in one way or another. So I'm going to stop sharing if I can. So I just wanted to use that as a brief opportunity to explain one of the networks that Professor James mentioned. And if it's okay, if Karen is ready. There's Karen. Yep, okay. So thanks very much. I would like to invite Dr. Karen Parkhill to make a short presentation.
Hi everyone. I don't know whether this is a good thing or bad thing, but I actually don't have any slides. I'm quite late to the table due to some confusion on my part about this meeting. So I had a quick chat with Richard on Friday and he assured me slides weren't necessary, but I'm seeing everybody's excellent presentations and regretting that now. But what I'm going to do is tell you a bit about myself, a bit about the plastics network, and I'm sort of going to end on, based on my particular interest, what I think are some important questions that need to be asked, or research areas that need to be explored a bit more. And I'll try and give you a bit of the UK policy context, but I'm by no means an expert on the policy context. So I'm Karen Parkhill. I'm an associate professor in the Department of Environment and Geography. I'm a social scientist with an expertise looking at public and stakeholder attitudes, norms, values, perceptions, etc., towards different environmental issues, which includes things like plastics. But most of my work has actually been based on energy and energy system change. And things like climate change and climate engineering. So I entered into sort of the plastic sphere of concern by wanting to explore behaviours, attitudes and attitudes and practices towards plastics. And I've attempted a few times to get funding in this area, trying to explore what are the barriers and opportunities for shifting people from different types of single-use plastics, but beyond sort of the typical things that have been focused on so far, like carrier bags and coffee cups. In fact, I wanted to do some fairly sensitive work looking at personal hygiene products like menstrual wear and incontinence wear, and obviously things like nappies and so on. But I haven't yet been successful in getting funding in that area, but I do think it's something particularly important to look at. And I've also been involved in bids to sort of try and set up interdisciplinary PhD studentships which cross the divide between the sciences and the social sciences to explore similar sorts of issues. And part of what I've been trying to do is not just work with the sciences, but also bring in the arts and humanities, because I think when you're trying to explore really sensitive topics, like I have been trying to explore, you have to find innovative methodological ways of engaging people with that. We had a brief discussion earlier in the question and answer session about the importance of cultural context. And whilst I've been focused purely on say, the UK, obviously we have a lot of different cultural contexts within the UK and different norms and values, and we need to be sensitive to that when we're trying to explore what the different barriers and opportunities are. So that was sort of my way in to exploring plastics research. And it became apparent when I was trying to put these bids together and when I was invited to put bids together that there is an awful lot of work happening across the University of York looking at plastics, but we often weren't aware of the diversity of that work. And I'd sort of decided with consultation with a variety of people, both within my department and outside, that perhaps what we needed was, first of all, I tried thinking about a centre, but I was told very swiftly that centres were not always the way to go forward. And actually what I could think about, given that we already have the waste network, is a sub-network. So under the waste network, we do have the interdisciplinary plastics network. Now, I'll be honest about this. We started this about 1.5 years ago, but we haven't got very far with it because just as we were about to launch, the dreaded COVID-19, of course, happened, which stalled all sorts of attempts to develop the network, get a public presence and so on. So we're going to be working quite actively on that. But interestingly, we have at that time, and we need to update it, we had over about 15 different departments and centres across the University of York who were doing work on plastics and across all of our different faculties. So we have researchers, as James has already outlined, in biology, chemistry, and of course environment and geography, through to our theatre, film and television departments, our social policy and social work departments, electronic engineering, archaeology, so all sorts of people working on this in obviously quite different ways, different foci and different sort of methodologies being used. So one of the things that I've got a goal of over the summer is to try and re-kickstart that network and update its membership and think a bit more clearly about what we want to do with it. Kind of an obvious thing we wanted to do was increase our publicity around or presence around plastics research, but also take part in events like this so that we have an international dimension as well, and we can network within and beyond our university. So it's a kind of watch this space when it comes to the plastics network, but hopefully we will have some development soon. So some of my key questions around plastics and waste in general actually are around behaviours, practices and norms. So I've already mentioned there are differences between the different socio-cultural groups, and I think one of the key issues around things like this is that practices and behaviours around plastics and other forms of waste are really hard to shift, largely because our behaviours and practices are quite habitual and we don't consciously reflect on them very much. But what has been quite effective, and we've alluded to this already earlier on, in the UK are things like the plastic carrier bag charge, which was actually, when it was first launched, very small. It was only 5 pence, which is a tiny, tiny amount. So certainly for the vast majority of people, it was completely economically viable for you to keep paying the charge if you wanted to. But what that started was a recognition or a switch in norms. So typically, you know, people would be going to supermarkets and shops and would be relying on the supermarkets and shops to provide the plastic carrier bags, when the plastic carrier bag charge came in, we saw a switch where it then became more typical for people to take their own bags or to be juggling things and dropping them as they're walking out the store, whereas before the plastic carrier bag charge, they would have perhaps been looked at as though they're kind of crazy. And actually what became atypical was relying on the carrier bags that the stores provided and paying the charge. Now, the charge has gone up over the years, and it remains to be seen whether it's still as effective as it has been. I suspect it isn't quite as effective. And of course, things like COVID-19 have also interrupted the good moves we've made away from single-use plastics. So things like coffee cups and so on. So it remains to be seen what sort of lasting influence things like COVID-19 and those sorts of things will have. But also in the UK, we've seen that plastics over the last few years has been higher on the public agenda due to this growing public discourse that's partly been prompted by key influencers like Sir David Attenborough and the Blue Planet programmes. And what that's led to in the UK is a few different policies or policy ambitions coming out, including having zero avoidable waste by 2050 and a target of limiting avoidable plastic waste by the end of 2042. I'm sure these things have been updated. These came out a couple of years ago. And then what I've also noticed recently is there's going to be a plastic tax for packaging on manufacturers, which should be introduced around April 2022. And I think one of the curious things we've noted, people who work in sort of environment research, is there's a clear difference between how publics and others have responded to plastics versus other environmental issues such as climate change, where it's sort of been a delay and ignore for quite a while, whereas plastics, it seems there now is some action being taken on it, albeit we would all argue not enough. So this has led me to sort of think about what are the key questions or research areas that I'd be particularly interested in and think need these sorts of teams that we've got here today working on. So unsurprisingly, it will be, first of all, how do we reduce waste in the first place? So looking at those behaviours, attitudes, practices, norms and habits that have been developed around things like plastic and other forms of waste. And how do we then shift those behaviours and practices beyond, I'm going to say the easy, but I guess beyond the niche. So I'm not dismissing the importance of things like carrier bags or coffee cups, but we know plastics is ubiquitous, it's part of everyday life, and we need to go beyond those things to have meaningful transformations in our waste, or reductions in waste really. How can we encourage more about reuse and repair? In the UK, arguably reuse and repair is currently held within a niche area of the middle class community groups, where it's gone from being something we all would typically do to sort of being almost seen as a luxury thing that you can do. And perhaps we've lost a lot of the skills needed to be able to do reuse and repair. How can we encourage manufacturers and retailers to stock more non-plastic alternatives and make these things more mainstream, again, rather than being seen as niche or in the sort of realms of those only interested in particularly the environment? And how can we encourage manufacturers and retailers to reduce the amount of waste produced in the first place? You know, arguably this new tax may go some way in doing that, but I've never seen wholesale changes made just by a government policy. And then I think there are key questions around the governance and responsibility of waste. How do we govern it, and who is responsible? And as we know, and as you've already talked about here, there's a key issue in terms of the UK side that we shift our recycling and our waste elsewhere, and it's kind of out of sight, out of mind governance mentality, or thinking that things like recycling solves everything, when actually what happens to that recycling, it often isn't recycled and is just transported elsewhere. So key questions there about the linkages across our different systems and beyond territory. We need to encourage publics and other stakeholders to recognise and advocate for change in the movement of waste, and this happens at local, regional, national and internationally, because my thinking here is that the vast majority of UK publics are not aware where our waste goes and what is done with it. We think we're fulfilling our environmental obligations in the UK when actually we're shifting the problem elsewhere. And that we also need to encourage all stakeholders, including publics, governments and industry, to design and implement effective pollution cleanup beyond territories. So we've got a waste problem, a plastics problem. We can't just ignore that. It's our responsibility to help and deal with that problem, again, going beyond our territories. And really something that's been touched about in other presentations, and I think needs a lot more effort, is around encouraging the support of innovative and creative solutions. So there's some of the key questions or kind of areas that I'm particularly interested in and think need work. I'm not saying this is a comprehensive list, but hopefully it gives you a flavour of not just what I'm interested in, but beyond what James outlined, some of the key areas of interest at the University of York, and you can see that there are lots of synergies with what you've already presented earlier this morning, and I'll stop there.
Thanks very much, Karen. Yes, and we cover a lot of issues already, hopefully that we can pick up as we go through the next round of presentations. But I just wanted to pause here just to check if there are any questions for Karen. If not, we can move on. Jan Gail, did you have a question?
Okay, yes, I have one. It's very interesting when you talk about the shifting of plastic consumption behavior, right? I'm not sure if I understand you right, but is it alternative materials to replace using a plastic is one of the shifts you are expecting to see?
It's a good question. It's not necessarily what I'm expecting to see, it's what I hope to see.
Yeah.
So I hope this is okay to talk about, but just thinking about personal hygiene products, things like menstrual wear, there are alternatives to the plastics that we've got. So there are reusable menstrual wear, but this at the moment is something that is small scale and niche, and isn't known about. It isn't. When our UK government wanted to tackle what they called period poverty, it was about putting pads and tampons into schools that maintained the use of intensive plastic wear, rather than thinking this is an opportunity for us to shift and actually have reusable menstrual wear that allows people to perhaps have a more sustainable solution to not just the plastics problem, but also things like period poverty. So that's just one example of where there are alternatives to plastic products. It's by no means the only example. We've seen it with things like reusable coffee cups, obviously reusable bags and so on and so forth, but it's just another example of where we can go beyond that. And what I'd like to see, and I think what this issue needs, is a lot more of that sort of innovation, but also making those innovations beyond the niche to be the norm, to be the mainstream, if that makes sense.
Yeah.
Yes, thanks very much, Karen. And I think, as Karen's saying, it is underpinning a lot of this are core questions about justice and equity and how the sort of the innovations might benefit some people or may impact others. Good. I think in the interest of time, we should continue with the presentations, and we should have time at the end to pick up on some of these ideas as we're discussing the kind of collaboration we might establish between York and Mahidol. So next on the agenda is Jan Brett. You okay to share your screen? And you have 10 minutes, if that's all right.
Right. Hopefully that's coming up on everyone's screen, and hopefully you can hear me. Yeah, so my name is Brett Zalek. I'm a lecturer, assistant professor in the Department of Environment and Geography. And my research interest is really in the fate and transport of chemicals in the environment. So I'm going to walk through a few of the things that I'm interested in, and then connect this with this plastic question, and then with some of the initial work that we're proposing to do in collaboration with Mahidol. So last year, this paper came out, and it was really eye-opening. Where 250,000 unique chemicals are registered for use globally. And this is significantly more than kind of earlier reports, and this is a much more comprehensive analysis, but it really shows that we are in a very chemically dependent world. And what also is important to know is that there's very little that we know about the risk that these compounds have on environmental ecosystems especially. So increasing usage of chemicals will no doubt result in increasing environmental exposure. And so when we think about chemical exposure, just to kind of highlight some of the sources and pathways that I'm interested in. So first we have intentional exposure. And so this is agrochemicals, when herbicides and pesticides are intentionally distributed across agricultural fields. But then we have a lot of unintentional pathways, and wastewater treatment is one of these. So the pharmaceuticals that we consume are very often poorly metabolized by the human body. So upwards of 90 to 95% of the active ingredient that we consume is released in our waste. And in the UK, for example, where that waste is then conveyed to a wastewater treatment plant, we end up with really complex mixtures of biologically active compounds. And wastewater treatment plants aren't traditionally designed to remove this type of contaminant. And so after the treatment process, these compounds can either partition into solid phases, so in the sludge, or in the liquid phase, which the treated effluent, and both of those solid and liquids are then released back into the environment, either directly into rivers or land applied, in the case of the UK, with biosolids. We also have legacy pathways of chemical exposure. And so, especially here in the UK with kind of aging infrastructure as it comes to solid waste, and then kind of how this interacts with a changing climate, increased flooding events are all stressing this infrastructure that the waste that we've generated over decades is being stored. And so when this infrastructure breaks down, we see this legacy exposure. And in the case of landfills, this is often industrial chemicals. So how my group goes about investigating chemical exposure and measuring chemicals in the environment is with mass spectrometry. And so mass spectrometry is an analytical technique that measures the abundance of chemical ions based off of their mass. So it separates chemicals by mass and then measures their abundance. And there's two kind of ways or I guess experiments that can be used. So we have targeted mass spectrometry, and this can be used to quantitatively measure specific compounds. So in this figure in green, what we have to do is, going into our analysis, we need to know what chemicals we're looking for and what those properties are. And then we can measure their concentration. And that's really good, and we can measure incredibly small amounts. But what we need, sorry, I think there's an echo. I'll keep going. But what we need is to know that these chemicals are in our samples. We need to know what we're looking for. Alternatively, we can use non-targeted mass spec, and this requires high-resolution mass spectrometers. So this really relies on kind of the latest technology. But what these do is these measure all of the ions that are in a sample, and then we can go back and try to identify different compounds. So a couple applications very quickly. So recently we measured, we used non-targeted analysis to measure chemicals in wastewater effluent in Colombo, Sri Lanka. And in the samples that we collected, we detected 9,165 unique chemicals. Not all of these are pollutants, mind you, but a really complex mixture of chemicals. And then using different databases and libraries of mass spectra, we were able to assign 13 chemical annotations. So this is, we were able to, from that entire mixture, identify that these specific chemicals were present. This included pharmaceuticals, illicit drugs, and industrial chemicals. Another approach or application that we've been working on is to identify degradants, so the transformation products of chemicals. And specifically in the agricultural environment, we've been looking at antibiotics that are exposed to crops. They get taken up by crops, and we want to know what they are transformed into. So plants are able to transform xenobiotic chemicals to make them less toxic. And in fact, that's what we were able to show using single cell mass spec, where we actually sample the contents of individual cells within plants. And so that's what this is showing. So in what we're proposing, and Dr. Thatchavee will talk more about this later, but a recent paper similar to the one I shared earlier came out, and they identified that there's 10,000 plastic-related chemical substances that are associated with the plastics industry. And of these 10,000 chemicals, a quarter of them are classified as being of concern. And this is based on them being persistent, bioaccumulative, and toxic, or very persistent and very bioaccumulative. So kind of two criteria that we use to measure risk and hazards. So what we are going to propose, and again, we'll hear more about this project later, is to use a combination of non-targeted and targeted methods to identify and quantify chemicals that are released from plastics as they degrade. And then we want to take impacted water samples. So these are waters that we believe are impacted by things like landfills and other sources of waste, and look for these chemicals associated with plastic that may be in there and may be posing risks to the environment. So that's all I have. Thank you all. And I think there might be time for questions later in the program.
Thanks very much, Brett. Maybe we could just take one or two questions if people have anything they would like to ask at this stage. If not, maybe we could hear from Kelly and then have a little break and take some questions for both Brett and Kelly. Is that okay, Kelly? Are you ready to go? Okay, good. All right, so thanks very much. So I'll hand over now to Dr. Kelly Redeker. Thank you very much.
Hold on. Can you hear me? Hold on. Oh.
Yeah, we can hear you. I think it's all
okay. Fantastic. All right. Yeah, there we go. Things are just taking their time. So while it's loading itself up onto the first slide, I just wanted to say thank you for letting me chat. And good morning and good afternoon to everyone. My name is Kelly Redeker. I'm in the Department of Biology at York. I'm a lecturer, originally come from Seattle, and that's pertinent because Seattle had a very big problem with sewage waste in its a large local lake when I was growing up, and they solved this problem by a biorenewable mechanism or a biotechnological mechanism. They planted a bunch of water weeds that went in and consumed all the sewage. And this was a great solution. The lake is now swimmable. It's in many ways a lovely place to be. But of course, the problem is that the weeds became dominant to the extent that now you cannot use the lake for the purposes it's intended to be used for without mowing the lake. They have to go out with a boat and basically mow the lake on an annual basis in order for people to get the job done and to be out and to be able to swim safely. And that combined with my PhD research into ozone effects has left me very perhaps jaundiced about technological interventions. And this is a theme that kind of goes through a bunch of my research and I think very strongly applies here. A lot of our solutions don't often tend to consider the whole picture, which is where the waste shed that Richard described really comes in, but also just understanding the ecological implications of these solutions to ecological concerns is something that I feel very strongly about. It's oftentimes we have tunnel vision and we see a solution and we think, okay, that's gonna do the trick, but we haven't necessarily considered all the ramifications of it. And that's, I think, where a lot of my research tries to step in, is examining these ecological implications. So my broad research foci, if you're gonna pin me down, is looking at biogeochemical function in complex systems. And so what that means is anytime you've got biology, chemistry, and physics interacting in a complex way within an enclosed environment, those are the things I find most exciting and interesting. And I apologize, I'm being a bit selfish in talking about my own research here. What I'm describing, though, is something that many people across the university are examining. And so this is a facet of what the University of York does. In terms of what I do in particular, and the things that I've been funded to look at, I particularly look at land use change and climate impacts. So how we transform or manage our landscapes and what that means in terms of ecological and climate function or impact. I've done a fair amount of work on sustainable agricultural solutions. And then with Richard and James in particular, I've looked at various waste and technology questions and implementation of solutions and how that works for the broader society, not just the people who are directly influenced or impacted by those technologies. And so what does this look like in the real world? Well, we've got a great deal of experience out in various coastal and wetland ecosystems. So just to give you a flavor of the things that we've looked at, I've worked on mangrove lagoons and mangroves, specifically looking at climate impacts. But in this case, I was collaborating with a woman, Stephanie Shaw, who was looking at waste influences, so sewage waste and how that influenced the climate impacts that mangroves derived. With James Chong and Thorne Helgeson and a number of people at the University of York and University of Essex. In the UK, we've looked at salt marshes, and salt marshes in the UK are very interesting. We've lost something over 70% of all of our coastal salt marshes, and we now recognize that we want them to be back. And so we want to restore them, but the restoration doesn't really lead to the same kind of ecosystem function even after 100 years. So we've been looking at this chicken and egg question of, well, why are these restored salt marshes not the same as natural salt marshes? What's the drivers of that, and how does that reflect in ecosystem and climate outcomes? like I say, we've done a fair amount of work on agriculture, and my whole PhD was on rice. We specifically looked at climate impacts, including methane and ozone degradation, but we've also recently been looking more specifically at mitigation and sustainability practices. So we've got a PhD student looking at storing soil carbon. We've got people who have explored the use of plant-based chemicals to replace pesticides that are already being regulated and taken out of availability anyway. And then there's this whole question about waste residue. You've got a crop, you've taken the grain, you're left with the stem and the stalk. What do we do with that? And that's a big question that needs to be answered. And how we deal with that has substantial implications to air quality and long-term climate and so on. And last but not least, we've got peatlands in the UK. That's a critical resource, and they are being managed in a range of ways, and that has implications again on their function and on their overall impact. So this is kind of the wetland ecology kind of work that has been done and is being done through various groups at the university. And I just wanted to take you on to a particularly, I thought it might be a particularly interesting project that we have working right now called Water for Farmers and Wildlife. It's run through the RSPB, or the Royal Society for the Protection of Birds, and the Environment Agency, a UK-based government agency that deals particularly with the environment and flooding issues particularly. But critically, it was also done in consultation with regional farmers. So the stakeholders who were actually going to be affected were addressed, and their concerns were taken on board. And so the project has really faced a number of different directions. The big question that's being asked here is, if we flood agricultural fields when they're not being used to provide migratory birds with habitat, what happens? So again, this is looking at what are the long-term implications to this solution. And the RSPB and the Environment Agency want one set of things, and the farmers want a totally different set of things, and they both need to meet somewhere in the middle if this is going to be a solution that can actually be moved forward. And so what you can see in the picture in the bottom is the pilot study where they had 4 10-by-10 plots that they filled, and there was supposed to be control. If you look behind the left-hand plot, just behind it, you can see a wet area. That was supposed to be a dry control, but because fields are not perfectly flat, the water flowed down and flooded that region. So that didn't work out so well. But with the one control that did stay dry and the other results in a very, very preliminary way, they felt that the fields were sufficiently similar at the end of the process that they should go ahead. And so what we have now is the beginnings. They've just started this, hence the fields are not totally flooded. They just started flooding them about a week ago. These are now over a hectare in size fields. You can see the bunds are there and they're being flooded, and they will be flooded for up to a year. And next to them, there will be a paired control so that we can see what the field without flooding looks like versus the field with flooding. And if we're lucky, we're going to have 3- and 6-month flooding or flooded fields as well, but that's debatable. One of the big questions and concerns of the Environment Agency is water abstraction. Some people draw from aquifers, and we're all aware that that may not be the best solution. And some people are drawing from rivers locally and nearby. And during the summer, those rivers may be water poor. And so we have to be aware and sensitive to those water issues as the project progresses. But what's happening here is I'm looking at the chemical and physical characteristics of the soil and water column. Mark Hudson, who's quietly in the background, is looking at the earthworm community, and Sarah Pillane, who's the RSPB representative, is looking at bird surveys and doing water monthly measurements with a simple handheld probe. And so this is an interesting project, and that ties together a lot of the themes maybe that we're talking about. It's a technological, or it's an intervention to provide a solution, but we aren't really sure what the long-term outcomes are going to be. So we're testing those so we can be sure that we are not causing a greater harm by providing what seems to be a relatively straightforward solution. And with that, I didn't want to take up too much time. I know I only had 10 minutes. So I was going to close off and let people ask any questions if they had any. Thank you very much.
Thanks very much, Kelly. That's marvelous. Thank you. And hopefully our friends at Mahidol have got a flavor of the range of expertise at York and the way that we work in interdisciplinary ways, and also engaging with stakeholders in identifying and implementing solutions. So this is where we have a little, this is the end of the York presentations. I just wanted to check whether there are any questions for any of the speakers at this stage. I'm aware we don't have much time, but if there is anything that...
There's a question in the chat.
Oh, I didn't see that.
So it's my... Hello.
Oh, okay. Would you like to ask it?
Yes, just we I think in the beginning of this month we have the explosion of the polystyrene styrene monomer plant in Thailand. It's quite a big explosion. So we did some collection of rainfall and runoff. So we done all the analysis. But if you're interested in using that sample, we will keep it for you.
That would be phenomenal. Yeah.
Yeah, we cannot find this opportunity anymore.
We have
Once
like
in a
100,
lifetime.
we have like 122 samples sending from people in Bangkok. If you're interested, we can post it to you, Brett.
Let's talk about that. Yeah, that seems really interesting.
Yeah. I was thinking about sending the sample to you, but it's quite costly.
I'm sure we can figure something out.
Yeah.
So my question for the Kelly, you said that you use the water from aquifer or surface water. That is, you mean a good water. What if you use the treated wastewater? Is it acceptable?
Well, I think James may be better suited to answer this question. In the UK, the use of treated wastewater is still a bit of a challenge because you have to demonstrate that the bacterial counts are sufficiently low that they will not be problematic. And I think that people are still looking for ways of, and James, please correct me if I'm wrong. I think people are still looking for ways of guaranteeing the criteria are met consistently enough and cheaply enough, as in the test should be quick and cheap, so that can be used. But I think that is an absolutely useful approach in many locations, but it does face that one contamination issue. But it is very nutrient rich, right? Nutrient rich and a very excellent resource. It's just the contamination issues.
We have a question from Acharya.
Yes. Okay. Yes. Sorry, I lost my internet connection sometime because big heavy rain in my house. So I'm not quite sure during the presentation of Professor Brett. Do you have any part of the research related to the microplastic in fresh water or microplastic in sea surface water or in sediment? I'm not quite sure because right now in Mahidol University we have start some part of the study for microplastic in sediment in sea surface water and also in bivalve like oyster and in mussel and blood cockle. Okay, so I'm not quite sure that you already have any part of the research about that. Thank you.
Okay, thank you. Could you quick answer, please?
Yep. So we have done a small number or a small amount of work on microplastic detections. I think one thing that we do have a lot of capability for as well is nanoplastic detections, and in collaboration with our physics department and the Nano Center here at the University of York, have been working on methods to measure nanoplastics, a little bit more than microplastics, but we certainly have that interest, and then also, of course, just to pitch the chemical side again, the chemical interaction between microplastics and the environment.
Thank you. Thanks very much. I think obviously there's lots for us to talk about, but in the interest of time, we still have some more presentations from colleagues at Mahidol. I think we should move on. And next on the agenda is Ajahn Thamanipon. Can't see.
Okay, can I share the slide?
Sorry, I can't see. Oh, okay. Good. Yes. Thank you.
Okay. Thank you very much, Professor Richard, for inviting me. I'm Joey. Maybe my name is too long. Okay, from the Tropical Medicine, Mahidol University. Actually, my research is related with the microbial risk assessment. And in terms of the quantitative microbial risk assessment, I try to estimate the risks in water and wastewater for different reuse purposes. And also I conduct the chemical risk assessments as well in the quantitative way. But today I need to give a talk about the current situation and challenge of waste management in Thailand. Maybe some professors know more than me, like Professor Orathai, Professor Acharya, Ajahn and Ajahn Monchai. Please support me. Okay, first of all, I want to introduce about the type of waste in Thailand. We have the 4 type containers. The organic waste in the green one, you can see this is all organic waste. The recyclable waste in the yellow ones, and for the hazardous waste in the red one. And if you don't know like which kind of waste, maybe some people dispose into the general waste in the blue ones. This one you can see the waste container in the public area, but for the household it's still mixed. For the waste management system in Thailand, I want to show you about the source. The truck will collect the waste from the household or from the market and department store and so on, and go to the transfer stations. And we have the sorting center, but not all in Thailand. And the separation of the waste, the valuable waste like paper, plastic, glass, metals, and so on will sell to the informal sectors. And then the residue will send to the landfill, and we have some sorting center again at the landfills, but always like an informal sector, as Professor Orathai mentions. And this is the disposal size in Thailand. We have approximately 80% of improper disposal that's related with open dump, open burns, and also incineration without air pollution treatment. But we have only 20 proper disposal sites in Thailand right now. For the informal sectors, just like help us to recycle, and you can see like in the private collections, like a car that can go to the village and get plastic or paper and then send to the junk shop, sell to the junk shop. As well as the waste picker, or you can call scavenger at the landfill sites. They can earn some money from the landfill by selling the plastic and some kind of valuable materials. Right now, the waste generation rate in Thailand is approximately 1.1 kilogram per capita per day, and we produce 73,560 tons a day in Thailand. And the highest production is in Bangkok. It's approximately 11,500 tons a day. And this is the recycling volume and rate of the plastic waste. The tendency of the recycling is increasing continuously, and in 2007, we have approximately 75% recycling volume of the plastic waste. But now in 2020, you can see even though the amount of municipal waste in Thailand is increasing in 2018, 2019, but it's decreasing in 2020 because of the COVID crisis. And like maybe the waste of Thai people is reduced because of limited of the demand and the COVID crisis. But however, the plastics waste is increased approximately 15% because of the container and the packagings. Next is the National Master Plan. Now, I would like to show you briefly about the National Master Plan for Waste Management in Thailand, 2016 to 2021. This is the framework. We encourage 3R concept, as Professor Orathai mentioned, about the reduce, reuse, and recycle, and try to establish the proper disposal method, try to make like a centralized facility, promote waste utilization and waste to energy method, like enhance to build an incinerator that can create electric cities. And the goals of the 2016 to 2020, like more than 75% of municipal waste are disposed properly, and more than 50% of waste separation at the source. This is the key thing that try to help for the waste management in Thailand. For the measures, try to stop using plastic bags and styrofoam packaging, and try to promote the environmentally friendly products. And they also improved and revised the law and regulations that related with the waste management in Thailand. And for the third one is develop the database and promote, because right now it's limited for the people to see the database of the solid waste, and we have only the quantitative data, but in a year, but you don't know what is the real and the composition of the waste. Moreover, when we say about the plastic waste management, the government focus on the plastic in the marine, and they have the plan to reduce the plastic marine debris at least 50% by 2027. Then, so right now we have a lot of interesting research topic about the solid waste in Thailand that you can get the grant from the national sectors, like waste to energy, microplastic, marine plastic, or material for analysis of solid waste, or data science that related with solid waste, or socioeconomic tools, willingness to pay, or policymaker, and also human behavior changes. This is like a hot issue topic for the solid waste management in Thailand, that some people can get the grant from the national sector. I myself and my team have an opportunity to go for the material flow analysis of waste in Thailand, and I have to go to survey at the site-specific waste to find the composition of the waste. And I want to show you some of my results that I already went. For the Thailand, you can see we have like 6 regions, and the highest production of this is in the central regions, and then you can see like we still have a lot of improper size and proper size in origin, and the recycle rate is still question like you can calculate correctly or not. And I go to survey with my team, and we found that in all regions, you have like the main composition, like a top 2 for the organic waste and plastic waste, as you can see in my slide. And then the composition in detail, like as Professor Orathai already mentioned, the plastic waste include the HDPE, LDPE, PP, and multi-layer bag is will already banned soon in the future. So that's all my presentation. That I think the research topic should be related with this interesting title, or maybe you can think more about that. We can collaborate about this topic. Thank you very much.
Thank you very much, Ajahn Joy. That's really helpful. Give us a sense of the situation in Thailand and across the different regions. And also, I think it's very useful to have some images to see what waste management looks like in Thailand and the different kinds of people who are involved at different stages. So thank you very much. If you could, sorry, would you mind if you can end the slide view, then we can see everybody and I can just check if there are any questions. Okay. So, Kelly's got a question, sorry.
It's good that I waited a bit because my question is about these kind of informal pickers. And I was wondering, in the current situation, is there any intention of formalizing this community and maybe making it a bit more professional and a bit more rigorously defined what is to be brought and what is not? Because it seems like it's being done at a large scale. That seems like it may lead to challenges in how the waste is received and what can be done with it. So I was just wondering, from all of you who have been talking about these informal structures that are kind of address or going through the waste and changing its characteristics, I'd be interested in your thoughts on that.
Okay, thanks. John Joy, would you like to respond? Sorry, I think you're on mute.
Maybe Professor Achara know more about this one than me, because I just only one time that I experience and see the informal sector at the site.
Okay.
Actually,
thank you very much.
Okay, thank you. Ajahn Achara.
Okay. I would like to share some part of this about the informal sector. Even in Thailand, we actually it's not legal or illegal, but we have part of some information or try to educate or try to give information for informal picker, for scavenger in that we have from Dr. Chui that he mentioned about the survey, that we have a lot of informal disposal site. It's like open dump, and we have a lot of scavenger came in and sorting part of the recyclable material. So the thing that we can do, like try to educate people, try to educate scavenger in that area, how to sort and how to avoid the risk or the hazardous material from their work, something like that. Do I answer your question?
Yeah, I think that's very, very helpful. I think perhaps as we come towards the end, this perhaps is an issue that we would want to consider as we develop a research collaboration. The whole complexity of informal governance arrangements, the informal dump sites, the informal working arrangements of scavengers and others involved in waste sorting and treatment. So maybe, again, in the interest of time, not to sort of dismiss the importance of this question, I think we should move on to our next speaker, who is Ajahn Athit. I can't see you on my screen. Are you? Please, if you could take the stage and share your screen.
Can you see my screen?
Yes, thank you. Could you? Perfect, thank you.
Okay, again, good afternoon, everyone. My name is Athit Posi. I'm now working as a lecturer at the Department of Environmental Health Sciences, Faculty of Public Health, Mahidol University. And my research interest is mostly on environmental epidemiology, means that I'm trying to find the health impact of environmental factor using statistical and epidemiological modeling, especially the impact of air pollution and climate change. But today I'm excited to talk or share the information with you, just only the general information of the health impact of plastic. So that when we take into account the health impact of plastic, we need to take into account the whole life cycle of plastic, starting from the extraction and production of plastic until the disposal of plastic waste. Because in every stage of plastic life cycle, they might release the chemical substances. As you know, when we consider the health impact of plastic waste, the plastic waste itself might not pose a significant risk on human health, but the majority of the health impact of plastic waste come from the toxic substance or the chemical substances of plastic and plastic products. As you can see here in the life cycle of plastic, in every stage of plastic life cycle, they will generate or release the toxic chemical into the environment. And after those plastic chemical or toxic substances released into the environment, it can be contaminated in the we call the biosphere, which can be contaminated as air pollution, soil pollution, and also water pollution. And those chemical substances can be contaminated and accumulated in the food chain. And we, as a human, can expose to those chemical substances through agricultural soil, terrestrial and aquatic food chain. And also we can expose through the water supply if those toxic substances contaminated in the water. And as I mentioned to you earlier, when we consider the health impact of plastic waste, we need to take into account the whole life cycle of plastic, starting from the extraction and transportation of fossil fuel of plastic until the plastic waste disposal. From the first stage of the plastic life cycle, we call the extraction and transportation of fossil fuel for plastic production. In this stage, they might release some toxic substances like polyvinyl chloride and also the styrene monomer, if they can leak into the atmosphere. And these processes, if we expose for a long period of time, the health effect can be generated, such as cancer and reproductive and developmental problem, and also the impairment of the immune system. And in the stage of refining and manufacturing of the plastic additive, in this stage, the chemical substances can be released and also accumulated in the atmosphere, also in the hydrosphere and lithosphere as well, as we know as the air pollution, water pollution, and soil pollution. So that if human exposed to those kind of chemical substances contaminated in the environment, and then the adverse health effect can be generated, because some kind of chemical substances can be carcinogen, means that it can be pose the cancer on the human. And also in the consumer use, we as a human can expose to chemical in the plastic packaging. And also we can expose to the microplastic through inhalation, ingestion, and also in the skin contact. So that after that we can expose to the chemical substances in the waste disposal, or we can do waste management processes. In these processes, especially for the waste to energy section, because in this case, waste to energy section, sometimes we use the incineration process. In this incineration, the byproduct of the incineration, we call the air pollution. The main air pollution can be like the critical criteria air pollutant and also hazardous air pollutant. For the criteria air pollutants such as NOx, nitrogen dioxide, nitric oxide, carbon monoxide, and also particulate matter. And sometimes this kind of pollutant can be can make the reaction in the atmosphere and become the secondary ozone gases. And this gas can cause both acute and chronic effect. For the acute effects mean that it can cause the respiratory and cardiovascular problem after we expose for short period of time. But for the long-term effect means that we expose for this kind of pollutant for longer time, and then the health effect can be occur, such as cardiovascular disease and also the cancer-like illness. And also the byproduct from the incineration we call the hazardous air pollutants, such as polycyclic aromatic hydrocarbon, dioxin and furan, and also polychlorinated biphenyl. This kind of pollutant can pose the significant risk, both short-term and long-term effect. For the short-term effect, it might cause some irritation to our eye, throat, and also the skin irritation. And for the long period of time means that we expose a little bit, but we expose for longer period of time. It might cause the significant risk on the health impact, such as the cancer-like illness, and it might affect to the general, the next generation, means that the child might have like a low birth weight, something like that. And this kind is the example for exposing air pollution, such as hazardous air pollutant and criteria air pollutant, and health effect can be occur later on. And this slide show the multiple pathway for human to expose to the microplastic through the seafood. And as you can see here, we as a human can expose to microplastic through multi-pathway. If we eat like a cell food, fish and shrimp, something like that. Although recently there is no evidence showing the adverse effect of microplastic on human health, but we believe that the best solution to reduce the health impact of microplastic or nanoplastic is to reduce the production of plastic or reduce the use of plastic packaging. Because if we can reduce the plastic production or reduce the plastic use, means that the chemical substances of plastic and plastic product might be reduced. And after that, we can reduce the health impact of the microplastic consequently. So this is the end of my presentation today. Thank you very much.
Thank you very much, Ajahn Atit. That's very helpful, and again, it demonstrates just the wide range of expertise and diverse interests at Mahidol and similarly at York. We are quite late on time, so are there any sort of quick questions? I think if everybody's okay, perhaps we could move on. We have one final presentation from Ajahn Gao.
Okay. Can you all hear me?
Yes.
Yes. Okay. So I will talk about my work.
Sorry, could you put it on slide display, I think?
Oh, okay. I want to talk a little bit about my work on microplastic contamination in freshwater environment in Thailand. So I plan to talk about marine debris first, because it's because of marine debris issue that people pay attention on microplastic as well, and most of the study were in marine environments, not very much in freshwater environment. And in the time that I was conducting this research, so I did in freshwater environment in Chi River, Thailand. So we all talking about plastic, and we consume a lot of plastic, and it's become issue in the environment, and it's also our health. Yeah, we found this microplastic in environment, in the media, and also in fish. This one is a study from China, and also in mangrove area fish as well. not only in freshwater environment and seawater environment, we also found microplastic in rock, salt rock, and sea salt and lake salt. So we cannot really avoid it because we eat it, we consume microplastic every day. And also in drinking water, there is a research found high percentage of microplastic in drinking water around the world. In worldwide, 83%, USA, Europe is like more than 70%. Yeah, so we all are eating microplastic every day. So they also found in other kinds of drinks as well, like beer, soda drinks, soft drinks. So yeah, this is the study in Mexico. From my study, I did in Chi River in Thailand. Chi River is the longest river in Thailand, located in the northeastern part of the country. This Chi River is a protein source for more than millions of people living in the region, and people also use the water for water supply and water for agriculture. And in the same time, municipal wastewater has not been properly treated. Most of the community discharge their wastewater directly to the river. Also, pesticides, like toxic chemicals from agricultural area around the river as well, this polluted the river. We can see this when we do survey, like, you know, pollutant from from community discharge directly to the river. And it's part of the Mekong River basin, so the water end up in Mekong River. My research divided into two parts. The first part is Upper Chi, Upper River. In the Upper River, we compare contamination of microplastic in environment, in water and sediment, and in arthropod. It's like shrimp, it's kind of arthropod as well. This is the abundance of microplastic in water and in sediment. If we go downstream, we see more contamination of microplastic than in upstream, both in water and in sediment. And this one is in the arthropod, the same trend. And microbiome is the most vulnerable species that their eating behavior accidentally consume more microplastic into body than other species. And this is the image of microplastic that we found both in water, sediment, and arthropod. There is fiber fragment from pellet. This is pellet. This is abundance of microplastic in water and sediment. We can see that the majority are fiber, both media, fiber. And if you see the color series, you can see very clear. This is purple, red, dark blue, black, blue, orange, and gray. It's smaller microplastic come from bigger one, the same shape, both in water and in sediment. So it cracked down when it sink in the environment. It could break down from larger side into smaller side, and of course it will become nanoplastic at the end. And this is a polymer type of microplastic that I found. Most of them are polypropylene. Polypropylene fragment is the most in water. No, polypropylene fiber is the most majority in water and in sediment and also in arthropod. The second abundance is polypropylene fragment. From this figure, we can clearly assume that polypropylene fiber come from fabric, from washing clothes. It leak, it tear out of the cloth, and then it become mixed in wastewater, and if that wastewater is not treated, 100% of the fabric fiber will throw into the river. For the fragment, PP fragment, I assume that it comes from plastic use in the kitchen or from single-use plastic, because most of the single-use plastic are polypropylene in Thailand. Yeah, and also in arthropods. So it's very clear that human activity, not only how we manage waste, but how we manage wastewater as well, that can contribute to microplastic contamination from fresh water, and it will also end up in the marine environment as well. And it's also affect arthropod, like animal for food for the people around the area. So we really have to put regulation on how we treat our wastewater and how we regulate how we treat our plastic waste. So the second part is the Lower Chi River. From the Lower Chi River, since it is more populated than the upper river, for this one, I study abundance of the microplastic and link with the hazard level in the environment. Here is the abundance. Going downstream, we find more microplastic both in water and sediment. And this is the polymer type. We can see very clear that the community really pollute the river by, a lot of polypropylene that is contaminated in the Chi River downstream, both in water and in sediment. And the second majority is PVC, and then PE, and then PET. For this one, this is a hazard index that I refer from study of Littner, that he created this index calculation, and then I use it with my observation from the field. We found that if we go downstream, this is upstream and this is downstream. If we go downstream, we can clearly see that the hazard risk index is very high. You can see from the red dot here, the size of the dot is the concentration or the abundance of microplastic, and the color show that this is a high hazard in water and in sediment. Downstream, we find more hazard, and the hazard, what is the meaning of the level 5 and 4 is shown here. I will just quickly go to next one. This one is pollutant loading index. Is it how much the microplastic is loading into water media and in sediment? As we can expect that the lower downstream, in the downstream, we see more loading index than upstream because of the accumulation of microplastic from downstream as well. But in the sediment, we found that at this side, the red dot side has the highest loading index. Because of this place, we have very big community located here, and is polluting, discharging their wastewater directly into the river, and the microplastic that is having density higher than water, it will sink to the sediment. So at this area, the sediment is very highly polluted and contain PVC, and PVC is the most dangerous monomer of all, comparing with other types of monomer. And this one is the calculation of potential ecological risk index. We can clearly see that the whole range of downstream Chi River is in extreme toxic to the ecological. So it's very clear that human activity polluted a lot of microplastic into the river, and it's caused threat to ecosystem of Chi River. And I think the strict regulation should be in place to control how we manage our wastewater, because now Thailand have around 20% wastewater that is treated, and also together with how we manage our plastic waste. So the next plan is like Brett has mentioned earlier. We are focusing on how we manage plastic in the landfill, right? This is open dumped site in Thailand. This figure, this is like as long as 20 years of open dumping at this area. And this is like the leachate, and this is how local government manage to manage their waste. And they just, you know, do open dump. Some places like at this local government, they just dig the soil and then they put the plastic waste and other kinds of waste into this pond, and then they will cover with soil at the top layer, only the top layer, without any layer, HDPE layer in the bottom. So it's very dangerous, I think, because this leachate might contain a lot of plastic chemical and or monomer, like can be monomer, can be plastic additive that can discharge to the environment, surrounding environment, like surface water, surface soil, and also groundwater. So the next study that I will do, I mean, very soon now, I'm surveying the site that I can take the sample. So I will take sample and do non-targeted and targeted analysis to see how much chemical substances that is toxic contained in leachate and how it distribute to the environment, like surface water and also groundwater. Yeah. And the last one, I just want to quickly talk a little bit about global action against plastic pollution, that the work that I'm involved. There is a project that the other day that Richard found it on internet, and I'm involved in this. So it's called Crossing the Loop project. This project is funded by Japanese government, and it's done by SCAP and IJES, partnership with IJES. IJES is a think tank organization of Japan. And so it's because of, you know, the problem that we were just talking about. This project, they focus on developing circular economy of local partner. For this case in Thailand, they are working with Nakhon Si Thammarat municipality. They want to encourage to have this circular economy to run in their city, and want to transform the city to be more sustainable, to be more like organized and also have, you know, to manage their waste better and use this market-based regulatory and local action. At the end, it can help our health of the ocean, you know. So we need to have international agreement. We need to strengthen national policy, and we need to manage our river system, not to pollute the plastic waste, microplastic into the river. And of course, we need to strengthen a municipality on their solid waste management as well. So this project they are doing in 4 countries, 1 city per 1 country. In Thailand, Nakhon Si Thammarat, Malaysia, Kuala Lumpur, in Vietnam, Da Nang, Indonesia, in Surabaya in Indonesia. And this is a project team, and they have advisory committee, so many UN agencies and many non-for-profit organizations around the world, including SEI, that's involved in this as well. And yeah, so the output is that they want to make a baseline data for plastic waste generation of each city. When we know this baseline data, we will better develop our action plan for plastic management. They also produce innovative technology to help the city as a tool for the city to use, or also for the citizen to use to strengthen the plastic management in the city. In this case, they use FieldNote application. Is a mobile application that the citizen can upload into their smartphone, and then they can take photo of plastic waste, and then the photo will show in the local government system, and the local government system can know exactly where is the location and go there and solve the problem. Yeah, this one is produced by Japan Space System with the support from Mahidol University. And with these two of these tools and the action, the data, the baseline data, then we can make this action plan by engaging every stakeholders in the city, like government, public sector, school, community, recycling sectors, and many more to enroll in this action plan development, and then the city will adopt this plan as their development, and then they will propose the funding from the government at the end. This is our ultimate goal. So yeah, that's all for my presentation. Oh, if you are interested in more information about this project and online, they also have online courses on marine debris. You can access to this link or just scan this QR code. Thank you.
Thank you very much, Ajahn Gail. That's really, really fascinating. I mean, I think from Ajahn Gail and the Mahidol team, there's a whole range of work going on that really resonates with interests at York, and certainly I can see lots of opportunities for collaboration that would bring in not only the colleagues on this call, but other colleagues at York as well. I'm aware that we're running over time, but I'm reluctant to sort of just close without opening up the opportunity for a few questions. Would anybody like to ask any questions to any of our colleagues from Mahidol?
Yes, this is not a questions, but we have the chat with the Professor Kelly about the possibility to develop the research together. But I think many of you may be interested in this kind of research. In Thailand, I think we just do a little bit on the regulations allow us to use the treated wastewater from the industry for the agricultural activity or proposed during the time that we have no water or drought period. It can be diluting wastewater as well, because we have no water during that time. So the law is open for us to do that, but no one can answer us how the risk associated with this kind of policy. That thing that maybe Ajahn Kelly can help us to figure out.
I think that raises a really important bunch of questions about governance and policy and implementation, and these uncertainties, particularly as we face growing crises of water availability, water access, and water quality. Kelly, did you want to add something to that, Kelly, or James, perhaps?
I was just going to say, I think James has a lot to offer here, because he's the man in terms of quantification and identification of microbial communities. So it'd certainly be inclined to, important to have somebody, if James is overwhelmed with work, because I know he's got a lot on his plate, others might join us. But yeah, I think it's really critical. And as you say, with climate leading towards greater drought periods and stronger storm pulses. I think that has a lot to say to a lot of the discussions that people have been having. But yeah, we're very open and welcome to kind of develop a comprehensive study here, because like I said, I think it's when people get blinded on their topics that's when you miss the important stuff that's actually going to come back and bite you.
It's a very interesting area, and understanding how that water's stored before it might be deployed, and yeah, as Kelly's saying, what the potential contaminants are and whether there are any quick ways of mediating some of those would be very interesting.
And also one question I want to answer, the thing that Blake said that you both, Blake and Dr. Chutama, plan to do the analysis of leachate from the dumpster in Thailand.
Dumpster.
Is it correct? The landfill in
Yes,
Thailand?
yes.
Yeah. Is there any landfill in UK that we can do the comparative study as well? So
Definitely, and I
Do you want
think
to talk about that?
so that
yeah,
we can be the parallel study between the study in Thailand and UK. Which leachate is cleaner?
I think we might engage social scientists, because it's have a lot of factors that involve in the maybe difference in characteristic of the waste.
I think we can do the shipping, water shipping from Thailand to UK,
Yeah.
but we cannot do sediment shipping or
No.
the animal tissue shipping. No,
No, just water.
just water is okay. Another issue is about the thing in the chat box. Dr. Monchai raised the issue on the using the fabric bag in replace of the plastic bag. But yeah, we have something to deal with, not just shipping that kind of behavior. We have to figure out life cycle analysis, that whole thing that we can do the research on that. Ajahn Monchai, you might interesting in this issue.
น้องเฟิร์นอยากพูด
Thank you for all presentation. I would like to ask some question about your experience in UK. For example, about I have learned that in Japan actually. In UK, some city you have like RDF technology about 90%, but some city just only 40%. I would like to know how you set up that technology in existing. For example, in Japan, as you know, like Japanese is like top 3 in using plastic bag. Like one pack of cookie, in each cookie we have like one bag actually. So in each city we have individual management for solid waste. For example, in Osaka, like 95% is incineration technology, but 0% of RDF. And for my city, like Chiga Prefecture is in rural area, it's about 40% of RDF, and like over 50% of incineration is based on the human behavior. So in Thailand right now, currently we try to increase the RDF technology with other like incineration. This is the trend that we need to match our waste generation with the technology, because I think based on my experience, it quite take long time to change the human behavior and culture norm. Is like for example, if we don't have like such kind of COVID situation, we cannot change the people behavior, right? But what we can solve is technology. Like Japan, in mega city like Osaka and Tokyo, we have like over 15 million people, and they put the mixes between food waste and plastic sticks back together. The Japanese government cannot solve, but they improve technology. So I would like to would like you to share about experience in UK. How did you set the technology in eCity? Is based on policy or what? Could you share for us, please?
It's a fascinating question. It's a big one. I'm not sure who's feeling confident enough to respond at the moment. James, are you leaning towards the microphone?
I think it's like you say, Richard. It's it's a combination of many different things. So Yorkshire is quite a good example here because we are a very mixed region. So there's a lot of very rural areas as well as some quite large cities, and so it has required a concentration of facilities and more broader collection, and then moving waste to centralized areas in order to be able to process it. As was mentioned before, we definitely have landfill sites with leachate. There's one very close by, but actually the regulations have changed quite dramatically on what is now allowed to go to landfill. So a lot of those landfill sites are now closed to new business. Again, in our local region, a lot of our materials go to a site where they're sorted, and then there is waste to energy, so there is incineration, but the organic fraction's removed before that, the plastic fraction's removed before that. It's not easy and it's not perfect. That's definitely the case. But I think legislation in the UK has made a very big difference to what we're allowed to do with our waste, and that's exerted pressure then on how we deal with it.
I think, just to add a little bit, I think as we move forward to our research collaboration, the role of behavior change, of legislation, and the sort of complexities of implementation, all of these sort of governance arrangements need to be really brought into our research. I am aware of governance gaps in Thailand and how local administrations may provide land for a landfill site, what that means for local people, for farmers, the lack of management, the burning. And of course, something that I'm interested in as a question is, where does all this plastic come from? What is the commercial interest behind this huge use of plastic in Thailand? It's really quite staggering. And, I've noticed over the years that as much as there have been efforts to reduce plastic use, there is more plastic available. There's more plastic packaging. And as we heard from Japan, layers of plastic packaging. So there's another side to this story that we need to understand as well. Very conscious of time, but also reluctant to end a conversation that seems to be going so well. But I'd rather it's like this, that we have lots to say than we've run out of things to say. It certainly indicates that there is some real interest and value in working together around these issues, and lots of different dimensions to the problem that we could bring in to our collaboration. I guess we are probably approaching the time where we need to wrap things up. I know it's probably dinner time in Thailand, and it's people have other commitments. But this was intended really as a first engagement, so that we could present some of our research interests, some of our experience, our ongoing projects, our plans for future projects, just to get a sense of where there are points of common interest and areas for future collaboration. And I think it's very clear that there is a lot that brings us together, and there's real added value in us working together across Thailand and the UK. So I'm delighted that we've had this session, and as you know, that we have had so much to talk about, and that we could clearly carry on for much longer.
Richard, just a question: is everyone's email available somewhere?
Question.
I can list email address of people from Mahidol site and send to one. Maybe one can distribute to, yeah.
Yeah, sounds good. I can do that. Yeah.
Be great. Yeah. And the plan is that we will then have another session where we talk about the detail of collaboration.
Okay.
Yes, good.
Is that right? Yes. Just
Yes.
to check.
Yes.
Yes.
Yes, yes.
Yes, please.
Be good. Okay. Are we at the point where we should close? Is it for me to close?
Yes, and Dr.Thatchavee also here. Still, he might want to have something to say.
I think it's quite interesting as well, because when I hear from your presentation, I think that we could make some collaboration in the near future, because some part is I think is quite closely related. Like for example, as you mentioned about waste treatment and use in agriculture. I just got from one industry mentioned about this as well, because they just make like a paper industry, and then they want to make some using like a wastewater that are treated already to make like a sugar cane for that industry as well. And they want to make sure that something that is work perfectly in this way, just something like that. And I think like, for example, like because we got some change, because the behavior change. Before that, people just get some awareness about recycling, and also that how to reduce the plastics. But once we get a COVID-19 pandemics, think that just change in the opposite way. Just like, for example, as you mentioned about the like a coffee cup. Right now, we have to use that single uses. We can bring our own cup and use it, because people are just be careful about that pandemics, right? And then I'm not so sure that that things, because sometimes we say that pandemics just change behaviors. I'm not so sure that that behavior could change with that pandemics or not, because people just get used to with the plastic again, and then it's quite difficult to change it back with that. So I think many things that I think that we could get a collaboration on in the near future in this part, and many things I think interested in that part as well. So we for my view, I think that I strongly want our team to collaborate with you in any parts that we could join together. That okay. Thank you so much for to set up this meeting. I think it's quite fruitful to get these ideas at this point. Okay, thank you. Thank you everyone for that.
Thank you.
Thank you.
Thank you. So we should close the meeting by now, and just make a connection later. Ajahn will be collecting all the email from Thailand and
from Mahidol side, yeah.
Mahidol, and Vaughn will just exchange the email together. Okay. Let's see, for the next time we might have some MOU together.
Okay.
Bye.
Bye.
Thank you. Thank you.
Thank you.
Thank you. Bye bye.
Okay, bye.